Welcome to HVAC Sizing Tool, or HVAC Street, tutorial number 3, Entering a System. So with me today is Bruce Manclark of ClearResult.
Greetings.
And my name is Christopher Diamond. I work for the Northwest Energy Efficiency Alliance. This project has been funded by the utilities of the Pacific Northwest that fund NEA, as well as support from ClearResult. So the learning objectives of this tutorial are to be able to enter a system into the tool, be able to change system size, type, and basic parameters, and review the results. This is not an HVAC system design tutorial, or you're not going to be coming out of here knowing how to design a system. The folks who are attending, we assume, are HVAC system designers or installers, residential energy efficiency experts, and utility program staff. So just to be clear, this tutorial will not make you an HVAC expert. To get the most out of this training, you should be familiar with ACA Manual J and the basics of residential HVAC system design. The tool is based on ACA Manual J calculational method with some assumptions used to expedite small building system design. It is not an ACA certified tool. This report and any values, estimates, and recommendations herein are only intended to assist you in evaluating your options and should not be used in lieu of professional engineering services. Moreover, the results are as is, without any warranty or representation regarding quality, accuracy, infringement, or other usefulness. Okay, all that said, we have tested this in comparison to the ACA certified tools over hundreds of systems across the United States, and in all cases they resulted in the same system design choices. Okay, so if you recall from previous presentations, we used this tutorial house, a very simple basic house, entered the building, changed the options and overrides, and we ended up calculating what the design load of this house was. And for heating it was 28,300 BTUs per hour, and for cooling it was 19,500 BTUs per hour. Next, we're going to have Bruce talk to us a little bit about how we enter the system design and describe the system into this house, for this house.
As Christopher mentioned, we've already calculated the heating and cooling loads for this building, roughly about 30,000 in heating and roughly about 20,000 in cooling. Our first example is going to be sizing a gas furnace in a house, and we're not even going to size an air conditioning system for the house at all. So we'll go ahead and select gas furnace. And if you look at the graph down below called required heating, before we selected a unit, what you can see on the y-axis, or the axis that goes up and down, is capacity of the piece of equipment in BTUs per hour. On the bottom axis, we have outdoor temperature ranging from -5 to +65. The red line is going to be the equipment capacity. The gray line is the heat loss of the house. So there's lots of rules of thumb, and I think if you use one on here, you would put in a 60,000 BTU gas furnace. So let's go ahead and enter 60,000. It's going to be roughly 90%, so we'll go ahead and enter 54,000 for the output, and then we'll go ahead and hit save. As you may notice, those lines never cross. The system will always have excess capacity, and during the warmer weather, we'll cycle frequently, to say the least. Let's go in and enter a 40K gas furnace on the input.
So, Bruce, this line down here is what the house needs?
That's exactly right.
And this is what the equipment's providing?
Yes.
Okay, got it.
36,000, assuming a 90%er again. Go ahead and click save. And sure enough, the lines still don't intersect. Even at -5 degrees roughly, we still have excess capacity, but we'll get a whole lot less short cycling during the warmer winter months of the Willamette Valley. So that's just the gas site example. That's a good question. What that is actually our winter design temperature, and I said the Willamette Valley, and this house is in Kennewick, Christopher.
Right.
And that's why we have roughly a 7-degree outdoor air temperature.
Hey Bruce, can we do a heat pump now?
Absolutely. So this is going to the heating type, and we'll change that from a gas furnace down to a central heat pump. The system can also do ductless systems, but in a central system, we're assuming an air handler with individual rooms serving each zone of the house.
Great.
So please notice that when you select Heat Pump Central, your cooling type selection is also a heat pump. We'll touch on that later. Underneath the select heat pump mode, we can either do manual entry or we have some generic capacity curves built in there. So we're going to say that this is going to be a nominal 3-ton system. We'll go ahead and say 35,000. And this is an example only, so we'll go ahead and say the load temp is 17. Where do you get these outputs from? There's a few places. Obviously, manufacturers' literature, their detailed capacity tables will give it to you. And also, these are the 2 points that AHRI rates all heat pumps at. So we'll go ahead and hit save.
Uh-oh, it wanted a cooling number. Let's enter in a cooling number for now. Put it at 30,000.
Yeah, sure, 30,000. Layton will give it 1,000, even though we probably don't need it in Kennewick, Washington. There we go. Once again, we have the equipment capacity curve, and sure enough, the warmer it is, the more our heat pump can deliver to the house. The colder it is, the more heat the house needs. And where that point crosses is called the balance point. The nice thing about HVAC Street is not only that it shows it graphically, but if we go just slightly above the graph, you can actually see the exact calculated balance point of 23 degrees. Nice fit.
Wait a minute here. This says 23 degrees, and the winter design temperature, this little line here, is 7 degrees?
That's right. If we sized traditional heat pumps down to the winter design temperature, the system would be so oversized for 80% or 90% of the time. It'd be way oversized in cooling mode also. That's why we have to be very careful about designing our auxiliary heat to meet those few days of the year that it's actually below 23 degrees.
Right, so if we chose something other than a 2-temperature heat pump.
Yeah, why don't we see if we can put in a extended capacity heat pump.
Okay, so like a variable capacity heat pump that delivers 30,000. That's just the generic one.
Yeah. Go ahead and hit save. And wow, all of a sudden you can really see how the graph changes. The top red line is the highest capacity at that outdoor temperature this variable speed piece of equipment can deliver, and the bottom red line is the lowest capacity. So what we're showing here is 2 balance points. We have on the minimum output we have a balance point of 46 degrees, and on the maximum output we have a balance point of 14.8 degrees. In all likelihood, there'll only be a few hours in every year that this heat pump will need strip heat in Kennewick, Washington to help heat the house warm. Also, I just look at this graph and I see that this particular piece of equipment will probably be cruising around 60, at 60% of its capacity most of the year, which is a nice sweet spot. It won't make much noise. It'll continue to circulate the house, the air in the house, and should achieve high levels of comfort.
Awesome. And so we'll get into later in other presentations some more details about some of the variants of different types of heat pumps, how to enter in your own custom heat pump, but that's not for this particular tutorial. All right, Bruce, let's show them how to use HVAC Street to do cooling.
All right, let's go back and we'll change our heat pump central system over to a gas furnace. We've already got the size of the gas furnace selected. Let's go over and select that indeed we do have a cooling type. So go ahead to the cooling type selection. We'll hit air conditioner. Now it wants to know the detailed capacity of this particular piece of equipment. We go upstairs and we say, hey, cooling load is 19,500. The logical thing would be to put a nominal 24K system in, so we'll enter 24,000.
2 tons.
2 tons. Latent load again, this is in the desert. We'll just go ahead and enter 1,000.
All right, hitting save.
And the red line again is the equipment capacity table on heating. We scroll on down to cooling. We have the equipment capacity in cooling. And blue is for cooling, red is for heating. And we can see that where these 2 lines cross is roughly going to be 108 degrees. This will meet the cooling load of the house all the way up to 108 degrees comfortably. The summer design temperature for Kennewick, Washington is roughly 97 degrees. This will be a nice fit, and it will not short cycle too much during that 90 to 95 temperature bin that Kennewick is famous for.
All right, Bruce, so there's some other stuff on this page that we might want to cover as well.
Oh, absolutely. This equipment specification page doesn't get used in any of the calculations. It's just for record keeping. If you click on it, you can see that there's already a lot of manufacturers preloaded into that. We can enter model number, nominal size, and again, this is just for record keeping and specification management. Down below is the beginning of your duct design, which we'll cover in another tutorial. A lot of people are using flexes these days. The max per register is critical. Generally, most people do not want more than 150 CFM coming out of any individual registry. That helps for comfort and keeps noise to a minimum. Maximum duct velocity, 700 is the maximum, but you can change it. I've changed it with some hesitancy. Again, it's primarily a noise factor. Down below, we start to calculate heating and cooling CFM needed. It starts to go into calculating such things as available static leftover, and that is all used in our duct design calculations, which, like I said before, we'll cover in a later tutorial.
Great. All right, so there are a couple of things you want to remember as you're doing your system entry. The first thing is really make sure that your design starts really understanding what part of the house you're trying to heat and cool. Sometimes we're not trying to put an HVAC system in that serves the entire house. Other times we are. It's really useful, number two, to have your HVAC system capacity tables handy and at the ready so you can kind of look up and kind of see what's available. And remember that when we're dealing with heat pumps, you don't have to have 100% heat at design temperature. They will have some form of backup heat, so you want to make sure that they're sized to optimize the system performance and comfort, but not necessarily meet all worst case conditions. And of course, always remember to hit the save button between going from tab to tab. Congratulations, you've now completed the third tutorial of HVAC sizing tool. Assuming you've now done this getting started, entering a building, and now entering a system, you're ready to go on to duct design. If you want to know more about our other tutorials, go to www.betterbuiltnw.com, or you're welcome to join us at the Home Efficiency Forum, the annual event this year happening in Portland, Oregon.